Welcome to Tell Me More, the Allsteel podcast where design meets innovation and we explore the limitless potential of workspaces. In this exclusive series, we're peeling back the layers of workplace design. From the psychology of colors to the future of hybrid work, join us as we open doors to conversations with industry leaders, architects, and designers who redefine the modern workplace. This is Tell Me More, brought to you by Allsteel, because when it comes to designing the future, there's always more to discover.
Hello, and welcome to the Tell Me More podcast. I'm your host, Andrea Gauss, Director of Client Solutions with HNI, and we are kicking off a 6-part mini-series on sustainability. And we're going to talk about our 3 C's in succession here. Today, we're going to talk about chemistry, and then we'll talk about climate and circularity. And today, as our guest, I have with me Jennifer. Jennifer, will you please tell us a little bit about who you are?
Sure. So my name's Jennifer Warren. I have a background in materials science and engineering, the bachelor's degree from Iowa State. I've been at HNI for about 3 years now. Majority of that has been in sustainability. Just mostly working on the product development side of things and focused mostly on the chemistry behind our products.
That's great. Jennifer, we're thrilled to have you today on the program. And we were joking a little bit before we kick this off, like, how technical should I get? And I'm like, well, not super technical. We're still figuring out some acronyms as we go here. But I'm excited to talk about the important topic of chemistry and this notion of chemical transparency. So Jennifer, tell us a little bit about what is this subject of chemical transparency and why might people care?
Yeah, so chemical transparency is all about trying to get to know what is in the product itself, but not just what's in it, but like super deep down dive of what's in it. So all the way down to the periodic table of the elements type of thing. It's also very synonymous with full material disclosure. You might hear that term thrown around on occasion too. But mostly those are very, very, very similarly related to we're trying to get to the chemistry of what's behind the product. And why you would care, you can kind of think about what's in your product as a food ingredient label or something like that. So when you're concerned about what's in your product or what's in your food that you're eating, we're concerned about what's in the product that we're making. So we want to make sure that every product that we make does not have any harmful chemicals in it at all. To make sure that when you're purchasing our product from HNI, that you're getting the best product that we possibly could have. So when we think about things from a chemical side of things, and make better decisions on our side of things, you'll be able to make better decisions on your side of things when you purchase our products.
So you took me back to chemistry class and the periodic table of elements here. It is said that there are over 80,000 chemicals currently in commerce today, and just a few hundred have really been studied for health and safety. So when we look ahead, when we think about how testing continues, how we learn more through research, how do you think that this subject will evolve into the future?
Well, I think the biggest way to look at it, or the best way to look at it, is we kind of, in the United States, we kind of follow behind what the laws and translations that happen in Europe first, and then they kind of migrate their ways over here to the United States. So it kind of goes with big chemicals of concern or impacts, and then Europe will make a law saying, hey, this one, we've studied it, we noticed these are the health impact implications, this is the problems with it, and then we realize, oh yeah, we understand that, we do our side of things, and then we implement that into our own products. So a big example of this is probably BPA. Everybody's heard of BPA from back in the day. Europe made a law saying, hey, BPA has to be gone, it's harmful to our bodies, it causes cancer, and we're like, oh yeah, now we understand what that does. And so we go through all the effort to eliminate BPA from all of our products.
So you mentioned BPA. I've been hearing a lot about PFAS. We're hearing that consistently. And to your point, it started kind of over in Europe. It's the first place we heard about it. But we know that within the U.S., specific states are banning it in use cases like upholstery, carpet, etc. So how would you define what is PFAS for our audience?
So PFAS, so try not to get super technical, but it stands for per and polyfluoroalkyl substances. So basically what that means is anything that has a fluorine atom attached to it. The reason we don't kind of want these are because fluorine bonds so well at a chemical level that it's almost literally impossible to get it unbonded and out of the system. And what these do is these can cause cancer and all sorts of other health effects, reproductive issues, all sorts of things. And that's kind of why we don't want them in our stuff. They are used across the board in flame retardants, so which is why upholsteries kind of get a bad rap. They're also used in flame retardants for electronic components as well. It's also in Teflon, so anything that's used from coefficient of friction, or when you want to lower your friction. So ball bearings are another place that's commonly found. Some wheels or lubricants where you're wanting to reduce your friction, things of that nature. Also, a lot of it's in paints and stains as well. So you want to be careful there. But the biggest reason we want to be super, super wary of these is these are called forever chemicals, is what they're called. And because it bonds so well and you can't really get it off, it's going to be there forever. And so that's kind of the big struggle with what we have today, is trying to eliminate these. It's almost nearly impossible. There's no known way to do that to date. So we want to eliminate adding any of these intentionally from our systems at all. So we're going through all of our products to find where is our PFAS located, where is it intentionally added versus where is it just existing because it's been there for forever, and how do we differentiate between the two? It's just very complicated and convoluted, and it's just trying to find what is that threshold to determine what is intentionally added and what isn't. And each state, again, you mentioned it, every state has different laws around this, but I think the main goal for HNI in particular is to remove all intentionally added PFAS from all of our products. That's where
and you use the term intentionally added. It's difficult too, correct me if I'm wrong, because we don't sound like we have a list of these are all the chemicals, or these are even all the chemicals we refer to as PFAS. That is still under development. So
that list is ongoing, and it just keeps getting added to and added to. So essentially, we're looking for fluorine, though.
That's right. Okay, that's great. That's helpful. That's a nice little way to put a bow on it there. So, as you mentioned a few times, HNI and Allsteel, we're evaluating our materials and our chemical substances. So our goal is to evaluate 100% of them by 2025, because we believe that, there's a big effect on human as well as ecosystems are impacted. I've heard somewhere that the majority of our waterways in the US that we've tested have PFAS within them, as an example. So tell us, what's been the process for moving towards this material and chemical disclosure? How messy has it been? Share with us a little bit.
Yeah, messy is probably an understatement. It's a difficult undertaking, right? So I think the big thing is, the first step is getting material transparency. So what is actually in our products for 100% of our stuff? It's very, very difficult because often, like, some of the suppliers, they don't even know what it is. So like sometimes you get a distributor who buys it from somebody else, who bought it from somebody else, who bought it from somebody else. And it's like an off the shelf product. And you're just like, well, how do we track all that down? And how do we keep that data? So the data that goes into this in our database is massive. To date, I think we're roughly around 68 or 69% completed on this front. So we've got a little ways to go. But I think we're well on our way. That we've already targeted all of the ones that are the most likely to have health and ecosystem impacts, if that makes sense. So there are different materials that have been around a really long time, such as like metal alloys or glass, right? They've been around so long that we kind of know what's in them. Whereas like the things that are more new and relevant, so they're plastics, where you have BPA. We didn't even know that was a problem 30 years ago, right? So all of the new stuff that we're trying to use, that's where our focus has kind of been on. So that way we're attacking the most critical points first.
Important. Smart. So talk us through, because I know, sometimes we're literally asking a supplier partner of us to share their ingredients, which when you think about it, sometimes that's their IP, their intellectual property is how this stuff comes together to make a resin, to make a paint, etc. So how has that been? Has that been a little tricky?
That's a very difficult thing to navigate because it's their secret sauce, right? It's how they make their money. So they're not going to, let go of that super willingly. So we sign a lot of NDAs to make sure that we're not divulging, their secrets just willy-nilly, you know what I mean? Like we have, there's a specific way we have to go about that. But also the suppliers, like they want to keep that secret stuff secret as long as possible.
Sure.
With all the pushes from the different states and regulations and what's coming from Europe, a lot of them are going to end up having to part with a lot of that intellectual property, unfortunately for them. But fortunately for us, from the sustainability and health and ecosystem impacts, we can see more readily what is in our stuff and what we can, eliminate or, maybe change to a different material to say, hey, this one I think could be better. It might not necessarily be massively harmful, but we're like, this one's better. We want to use this one because it's better for the environment. Maybe it's a carbon footprint issue rather than a different, actually causing cancer. So you want
there's lots of tensions in sustainability where you think you're making one good decision on one front, to your point, maybe has a negative effect in a different direction. Talk about, I think this is kind of a fun story. We've run into a couple times where we haven't been able to discern what the chemistry is. The supplier doesn't even know. The supplier doesn't even know. So what have we done in those circumstances, Jen?
Yeah. So in those circumstances, we actually partner with Iowa State University as part of their polymer and food packaging consortium. And they have run several tests for us to determine, just as a baseline, what is the material. They can't get super in depth into it because basically what they're trying to do is they use what's called an FTIR, which is basically a fingerprinting machine for materials. So it's based on how good is your database. So Iowa State's database is pretty darn good, right? They've been around for a really long time, so their database is going to be good. So they can give us the general gist of, hey, this is polypropylene. Hey, this is polyethylene. This is, but it's not.
She's talking about resins, by the way. Those are plastic resins. Yeah, those are
plastic resins. So so those type of things, but they can't necessarily get in detail as to what colorant was used because it's just so low in percentage and threshold that it's a little bit harder to figure that stuff out. So and a lot of times, especially in the plastics realms, where you're going to see your worst chemicals are actually within like the releasing agents for your injection molders, where they'll spray on a releasing agent so that way it comes out of that mold really nicely. But now you're introducing harmful chemicals from that. So
back to that friction.
So exactly. Yep. So that's exactly where a lot of those tend to come from.
Okay. So put this in perspective. For an example here, our Beyond Architectural product line, how many roughly lines of data is there in that one product line? Do you have a guess?
Just shy of 30,000 lines of data.
30,000 lines of data.
But that's like the December's version, so I don't know what it is today. It's probably much larger than that. As I've gained more material transparency and chemistry, every single periodic table of the element on there adds another line. So
sure.
It'll probably be upwards of 30,000 just for Beyond only, not to mention Aspect.
Yeah, and all of our other product lines.
And all the any other product line that we're doing.
It's a heap and a mound, but we believe it's important because it has major impacts to not just our human bodies, but the ecosystem in general. So Jen, thanks for sharing with us this important body of work. We really appreciate it. And we're going to continue the conversation as regards to climate health and circularity. And so come back and join us again. Thanks for joining us on the Tell Me More podcast.
That brings us to the end of another fascinating episode of Tell Me More. We hope you enjoyed our conversation around chemistry. Stay tuned for the next episode of our sustainability series, where we'll explore the important subject of climate. As we sign off, remember that the conversation does not end here. Connect with us on social media at Allsteel and share your thoughts, questions, or even your favorite moments from the podcast. We love hearing from our engaged and curious audience. Until then, thanks for listening.